Studies suggest that methods engaging student participation almost double the learning as compared to plain lectures. In context of digital communications, the best way to learn digital communications is by designing a communication system. But there aren't many platforms that could engage students. A running digital communication system requires a broad range of expertise, starting from algorithm development, analog and digital board design, then low-level optimization, and finally testing of algorithms on DSPs or FPGAs. Consequently, two kinds of lab equipment exist. One is the conventional pre-implemented trainer, having a running digital communication system. A learner connects cables in different configurations to see different kinds of running digital communication systems. It's kind of learning how to swim without entering a pool experience. Other is high-end SDR solution. This provides learner with entering the pool experience, but experimenting with such system requires months of learning on how to program the system before being able to apply communication concepts. Moreover, it is too costly to purchase such a system in bulk and provide every student hands-on experience in regular courses. The theme behind our solution is minimizing unnecessary learning while keeping necessary learning intact. A communication system can broadly be divided in two sections, an RF front-end and a digital communication system. A simplified version of digital part would take data bits as input, map them to a constellation to generate an array of samples. The array is given to DAC, which converts it to analog signal. The RF front end is responsible for taking this baseband analog signal to a desired carrier frequency band. On the receiver side, RF front end takes the signal back to baseband. The baseband signal is converted to an array of digital samples using ADCs. Symbol timing offset and carrier offsets are removed, and we get a clean constellation that can be sliced up to get original data bits back. Ideally, to learn digital communications part of the system, the student should have flexibility to implement algorithms on commonly used tools like Matlab or LabVIEW, and easy interface with ADCs and DACs. To simplify things, we developed SCK30, which replaces the RF front end and is very easy to interface with a PC, where the digital part is implemented. Algorithms can be implemented on PC using Simulink blocks or writing Matlab script. They can also be implemented on other common platforms like LabVIEW or C++. That takes care of the first part of the problem. Next issue is interfacing with ADCs and DACs. One of the simplest ADC and DAC interface is that of sound card. One can drag and drop speaker or microphone object for DAC and ADC interfacing in Simulink. Or if one prefers writing Matlab code instead of using Simulink, he can choose from a range of functions like wave play or wave record. SCK30 appears as a sound card on computer, and so one can implement his algorithms on any platform that supports interfacing with sound card. So instead of sticking only to theory, the teacher can connect two SCK30s with two computers, design a transmitter and a receiver on, let's say, Simulink, and demonstrate a real-time system, providing practical insights along the way. Here is an example implementing 16 QAM transmitter on one SCK30 while receiver on another one. Let's start the simulation. The right plot is showing symbols timing recovery and left plot is showing carrier recovery. First, AGC is adjusting the received signal level. Now the symbols have started rotating in concentric circles after timing recovery, and these rotations are due to carrier offset. Now on the left plot you can see the symbol boundaries as carrier recovery loop is locked and a clean constellation is ready for the slicer. SCK30 is a cost-effective lab equipment option for digital communication and wireless communication courses, as well as for hobbyists. To make it easier for lab staff and self-paced learners, a free lab manual is available on our website. Our team is also working on a free online course